First part of this tutorial, we will create our base frame for our shed, which is going to include creating the studs, the corners, the floors, and the floor joints, and the foundation of it. And at the end of it, we should have a simple HDA that is being controlled by the box. If you go ahead and change the size of it, and we are going to dynamically change the values on this, like that. And we also be able to resample how many floor joints we want, and how many stud boards we want. And then we can change also the width of our values of our board, like that. So this is the first part tutorial, and let's get started. Let's start by creating geometry container. I'm gonna call it a shed builder. So inside here, let's create a subnetwork already. And let's start by creating a HDA, because we're going to want one central place for our parameters. So I'm going to call it a shed builder. So that's fine. I'm just going to put it in my project folder on HDA, like that. For the S label, automatic shed builder, I'm going to something like that, like this, so that I remember this is from the tutorial HDA. And now let's create it. Okay, so we have our parameters. So what I'm going to do is actually just put it on the side, and actually I'm going to also open up the parameters of the HDA, like that. And also you can put this on the side, because you're going to use them frequently, because I want to change our parameters that are actually going to change values on our shed from that window. Okay, so let's go inside it. Let's start working on our shed. Let's start by creating a box. So this box is going to be our block code geometry. So let's make it a little bit bigger, something like this. Now let's make sure that our box always sits on top of our geometry grid. So I'll to copy the y axis, y height, and paste inside the center y, and divide it by 2. So this should make sure it's channel reference only. And now it should always, no matter the height of our shed, it should always sit on top of our grid, like that. So the height, let's put something like 2.5, and shed something like this for the beginning. So now let's put in a normal. Actually, let's group. Let's start grouping. Let's start giving some of these polygons groups, because we need to start identifying parts of our shed. So for our floor, let's call this a floor. Make sure it's primitive type with primitives. Disable the base group and go to the key by normal. And we know that our normal, so this is going to be our primitive normals. If you go ahead and turn them on inside the viewport, so our single polygon is going to look at the negative y-axis, and that's going to be our ground. And if you go to node groups, look at the floor, and make sure that spread angle is 0. You should always select our bottom polygon only. So this is going to floor. Now let's duplicate it. Let's create a ceiling. So the ceiling is going to be exactly opposite. So that's going to be a normal that is looking upward. That's positive y. And then for the walls, it's going to be everything except for these, except for the ceiling and floor. But for that, we're actually going to, so we could just give it the, basically, we can just go ahead and disable this, and then the walls, let's call this a walls, just call it everything except with the arrow upwards, ceiling, and except for the floor. This should select only polygons that are on the sides, so basically everything except ceiling and floor like that. So this is going to be our walls like that. So now we have started separating some of these box into parts that we can identify later. So let's start by creating our frame for our shed. Let's start by putting down the blast node. Let's select, make sure it's at primitive, group type is a primitives, and make sure it's floor, and delete non-selected. This should leave only with our floor polygon. Let's put it somewhere inside here. So this is going to be our beginning of our frame of our shed. So put down convert line. So this is going to convert to the a single polygon to the lines of it. Make sure you do not select the connect path. So this is going to be individual polylines for us to use. And also we do not need rest length. Now what you can do is split it into the we can split this to the opposite pairs of our groups, because we're going to use a sweep node. So the thing with how we're going to create our frame is, let's put this inside. Let's put these converted lines into the sweep and select the ribbon side, ribbon type, and columns 1. You can see this should be our frame. It's going to sweep the polylines, but there is a problem that these edges do not actually match exactly. So that's why I want to get pairs of these lines, basically the opposite pairs, and want to subtract one of them and extend the other pair, so that they would so that it will be something that would be realistically made a frame from it. So that's how we're going to do it. So that's why we need to actually convert these to the pairs of the opposite side. So we can do this in different ways. I am going to put down a measure swap. And so I want to get the perimeter length, and inside this measure swap there's a very nice feature for us to actually bake out the range, visualized range, which is going to be a remap range of 0 to 1. So that means that since we are going to have, so this is not a square, so these two edges are going to be longer than these two, so the output value is going to be 0 and 1. So we can always tell that these two are going to be pairs, and these two also, because there's 0 and 1 values for them. One issue for this method is that, let's say that our input geometry is actually a square, let's say 2 by 2. Our parameter is going to be 0.5, because all of these are basically the same, and it can't give it 0 and 1 values for these edges. So what we can do is actually create a switch. So put down the switch, and we're going to check the X and Z size of incoming geometry, and if it is the same, we're just going to scale it by a little bit amount on the X-axis, so we make sure that when it is the square, it is a little bit bigger on the X-axis, and it's so that our measure stop always gives a range of 0 and 1. So put down a transform, and put it as a second input on the switch, and just scale it by 1.001, something very small and basically by eye it's really unnoticeable amount. Scale. Now go to the switch, and let's edit expression. So we're going to put down a if expression, if bounding box of 0, which is this geometry, the X size equals, and we can just go ahead and copy this expression, X Z size. If it is the same, we want to go for the input 1 and if not, that's 0, like that. And that should be it, like that. So you can see there's a dotted line, so this means that the solid line is actually, which is actually selected. That means that since we have size is 2 and 2, you're going to select the second input. And now let's say our size is 2.5. You can see it's automatically switched to the first one, so it's not, doesn't do any scaling. But let's say we have 2, so now it's actually does scaling on x-axis. Go to the measure stop, you can see now our range actually working. And also let's rename our attribute output, because it's not really a parameter anymore. So let's call it edge pair. And now let's split it. So split node is very nice if we have only, since we only have 2 different values and we want to output them in a different node output, we can use a split. So at edge pair equals 0, like that. So this should give us only the 0 pairs, and the second output is going to be our edge pair where is 1. So yeah. So now what I want to do is put on the wrangle node. So let's put it on detail only. I'm just going to open it up. We're going to want to write some Vex code for us to actually one of these pairs to expand, another one to subtract these polylines. So let's write this out. So let's actually put it on primitives, because we want to run through both of these primitives. This is going to, so initially I wrote it out as a detail, but actually primitives makes more sense. It's a little bit like 2 lines smaller code to write. So let's go ahead and write it out. So first of all, I want to get primitive points, all of the primitive points. So this is going to be array, which is a prim point, and the current prim we are running now. So that's going to prim num, like that. Now what to do is check if our prim PTs are actually 2 inside them. So if the length of it, of the prim PTs are equals 2, then we want to do anything else, because this method only is going to work if there are 2 points in each primitive. So just going to save us some headache if it doesn't if we are putting geometry that's actually is not applicable for this method for us to use. So let's get a position, so both of these points that we have inside our primitive. So let's vector position 1 equals point. Attribute name is going to be, and the point number is going to be a prim pt. So this is array, and we can access it by square brackets. Its members by square brackets. So we know that this array has only 2 values in it. So we know that every time there's going to be at index 0 and 1, there's going to be points in it. So just change the indexes on them, like that. So now we have these point positions. What I'm going to do is create the direction for our vectors to look at. And that's basically for both of these points. We want to make sure that they look at opposite points, basically outwards. So we're going to do it by subtracting this position from position 1 from position 2, and the other way around. So let's call it a vector. Let's call it the offset direction 1 is going to be, let's normalize this subtraction. So position 1 subtract position 2, like that. And just copy it and do it the same, only with the offset direction 2, and flip this around. So instead of position 2, instead of 1 minus 2, 2 minus 1, like that. So this should give us for outward looking vectors on both of these points. And now let's actually set the point position. So set point attribute. So it's going to be P for position. So the point number is going to be the accessed array indexes, and the value is going to be the position 1, so basically the current point position, plus equals. So this means that we are adding to this value, we are adding the offset direction. Let's add this offset direction multiplied by offset. So we do not have offset. We have to create a parameter on how much of offset we want to actually create. So create a float. Let's call it offset, chf offset, like that. So now we have offset, and for the mode we do not need. So that's good. What you do is go ahead and copy this. And instead of the position 1 to position 2. And make sure that you are also accessing index position 1, position offset direction 2. So basically we have the same thing, only for the point 2, like that. And let's create our parameter, like that. Let's take a look at it. You can see we are now increasing and decreasing our curve, like that. And since we have normalized this vector, so our vector is one length of 1, this offset should be represented of the real values in it. So if I offset it by 1, you can see in a grid it should go out by 1. So this is why we actually normalize this vector. So make sure that basically, because our vector by normalization means that it's 1, and if we multiply 1 by 0.5, it's going to move by 0.5 inside the viewport also. So that's why we actually normalized it, to make sure that its offset is going to represent actual values that we are going to use in other parameters. So that's good. Now we have this, and we can just copy it for these also, like that. Just merge them together, and then we are going to sweep them like that. And let's actually change these values. Let's start by looking at some building plans. So what I did, I found this image on the internet, and what we are now making is this bottom. So you can see there's names for them, and you can see it's called a long bottom plate, basically a plate where all of the stats are going to be on. So I want to make sure that one parameter is going to control many of these widths and thicknesses of these boards. So now we have to think about how wide we want our boards to be. So this is what we are making now. So, and our width is going to be controlled by this sweep. So this is going to be actually is going to be controlled by the HDA parameter. So remember, when I opened up this type parameter, I'm just going to go ahead and point this width, just going to move it inside here. So let's I'm going to put it inside the folder. I'm going to call this stat boards. So even though these are not technically stat boards, but they are going to be the same width as the stat boards. Many of them are going to be the same width. So I'm just going to put it inside folder stat boards, and there's going to be a width of it, like that. And we can actually go ahead and duplicate this. Just press D on any parameter. Let's put it also a thickness. So we're going to control thickness and width of it with stat boards. Now you can see we have these parameters that we can copy it. So that's good. So let's go ahead and copy this, copy relative reference of our width parameter, newly created. Let's go to this attribute and paste inside here. So the width of it, and so we want to add this width to one of these pairs, and other ones we want to subtract it, negative. And since and this width, since we actually move this to our parameters, automatically is going to reference it like that. So you see, it's almost works. But we need to divide this by 2, both of these, because they are we need only half of it extended, like that. So like that, you can see by dividing it, it should always, no matter what the width of it, what's the width of our base width of our stud board, it always should not intersect with each other like that. And now what we do is put down a poly extrude, and let's actually extrude it. And this extrude is going to be referenced by the tick next to it. So copy reference, paste inside here, like that. So the width of it is going to be maybe something like 0.1, and the thickness is going to be smaller, so maybe 0.05, maybe half of it, like that. So this is going to be our base for our shed. And now is actually a good time to start a little bit more of a cleaning up of our network, and actually start to kind of separate some of these parts of our network, because keeping networks clean and easily manageable really is the half of the battle. So what I'm going to do is, I really like the purple color, like that. So I'm just going to call it the bottom plate, something like this. So I just know what I have done inside here. So this is going to be our setup. So we can also give it so going to give it also pink. So maybe something like this. So, and now let's actually start creating our corners. So it's from this group selection, put down, I'm just going to copy this blast. And what I do is I want to get my walls. From the walls, I want to get the corners of it. So what you could do is put down a group. Oh, before we are moving on, let's actually do some coloring for all of these. So we have a poly extrude, and there's many, and now there are nodes that are actually referencing, that are being controlled by other, by our HDA parameters. So what I do is actually start coloring these. Go ahead, select these, and I'm going to color them green. So I know that this node parameter is actually controlled by some other parameter, so I can easily find it, something like this. So let's go back to our group. So for our edges, for our corners, what you do is actually make sure that it's at edges, and disable the base group, and select by the include by edges, and select the minimal edge angle. So this should give us these edges from the walls, from the blasted walls, like that. Let's call it corners, and there is a labs edge to groups to polylines, like that. What we're going to do is create our polylines from our corners, like that. And we can use this as our corners. Put down the sweep. And for the sweep, there's actually, we can actually use a square. The columns are going to be 1. You can see we are sweeping these already. And what's cool about this, we can control our width with the width of our stud board. Copy it, paste the width, and let's take a look at it. Let's just template it like that. And this should always be the width. Let's control the width. So this should always control it, follow up like that. One problem that we have right now is actually that our corners are actually intersecting with the bottom plate. So what we can do is actually move the bottom points up the amount of thickness of the bottom plate. So go ahead and put down transform, and we want to move only the top points, the bottom points. So in a group, add p.y equals 0, and make sure that you group by points, because this is not a group. It's not going to work if we guess from group, because it doesn't recognize this as a group. So that's why I make sure that it's explicitly at points. All I want to do is go ahead and copy the thickness reference and paste it like that. Like that. And this should ensure that we are not intersecting anymore, like that. Okay, so now our corners are done. And also one more thing, I want to in extrude of this, I want to also output back, like that. Okay. And also on the sweep, we can end cap single polygon, like that. Okay. And now let's actually create our decking. So if I take a look at this reference image, you can see that there's this floor decking is actually between the foundation and the actual stud pieces that we actually just created. So let's get the floor decking. So what I'm going to do is go to this bottom plate, put down the bounding box, labs mode bounding box node, and this node is actually going to create the bounding box around our bottom plate. Then put down a normal node. Want to give these primitive normals and put down a blast. So we just want to get the bottom polygon. So that's why make sure that's at primitives at n.y equals -1, like that. So this should delete everything except for bottom primitive. So this is why we actually put down a normal node, because even though these normals, we can see these normals inside viewport, always primitive normals, if they are not at the geometry spreadsheet and explicitly given, like inside here, they are not actually going to work inside something like these group parameters. So that, put down extrude, and then just extrude it on outwards on the bottom, like that, and also extrude output also back, like that. Let's put something like this, and let's take a look at it. So this should make sure that it's always at the bottom, and there's place for our foundation. So let's add this parameter to our type properties. Let's create a new folder. Let's call it deck, and just drag this distance inside deck. Let's call it deck thickness, like that. So this should be the only parameter that's actually going to change. And for the minimum and maximum, make sure that that doesn't go below negative. So since we also want to positive extrusion, and 1 is way too much, maybe some 0.1. So these values you can always change, but I'm not going to bother for them now. But I'm going to change this from tabs to maybe something like collapsible, so that they are always visible for me. So yeah. Okay, so we have our decking. Let's actually start working on our foundation. For the actual foundation, what I'm going to do is just copy this poly extrude, like that. I'm going to delete this distance, so we're going to give it a little bit bigger distance, maybe something like two times as thick as a deck thickness, and I'm just going to move it below my floor, my deck, and that will be our foundation. So actually, let's make it twice as. Actually, let's back up. Let's not delete this reference. I'm just going to increase it by 2, like that. And now let's move it under our deck. So put down the match size. And so we want to work with the y-axis. So what we'll do is put the maximum of our input 1 to the minimum of input 2, like that. So this is going to put it below our floor, like that. So yeah. So if I'm going to go ahead and merge all of these together, like that, this should be first steps for our shed. So, and if I'm going to put down a bevel, you can see something like this. You're getting very nice beveling on this, but we also want to our supports for our floor. So if you take a look at the image, you can see there's a floor joints. So this is where actually we're going to start to creating our own HDAs for us to start making some of these more intricate pieces, because we're going to use this HDA in many places. It makes sense for us to not to repeat the same network and just create the HDA from it. So let's get started. For our floor joints, what we're going to do is using these two polylines, actually just one of them, as a base for our as a place for our sweep node to create a floor joint. So what I'm going to do is just drag out. So we can use either this or this as a starting from us. So what I'm going to do is go ahead and put down a resample. So if you think about what we want to do is make something like this, resample this, and want to create a new polylines between the opposite edges of the points, like that. So this is where we're going to use HDA, and after that we're going to sweep them, and it is also going to be our floor joints. So let's create a subnetwork. We're going to use this HDA in different places, so it makes sense for us to create HDA. Let's go ahead and create a new. I'm going to call it connect. Connect opposite point, something like this. So the outer branch can stay. So where I want to put it, I'm going to put it on a custom. I'm going to put it inside this job folder under the HDA. It's basically my project folder. So, but this HDA is a good candidate for you to put it under your in your documents folder as HDA that's available for any project you're working on. And so for the edit label, connect opposite points, and I'm going to maybe in all caps put in a utility. So this is going to give me again more of understanding what this HDA is for. So utility means that this can be used as a global tool and not only for this project. So yeah, so this looks good. Let's create it. Okay, so inside basics, make sure that it's at the minimum input is 1, maximum 1, and maximum output 1. So the minimum input should be 0, because we don't want it to error out. If it's 1, it's going to error out. But if it just sits there, we can also just make sure that it doesn't give us this exclamation mark. So that's fine. Let's connect this to our HDA, and let's go inside here. So first of all, I want to separate our geometry. That's going to identify which is the separate. Let's connect the output, which is the separate parts of geometry that we want to connect together. For that, I'm going to put down a split node. A split node is good because we can use either a groups that's already defined by the user, or we can use the primitive absolute primitive numbers, or we can use the expressions. So this is why we're going to use it. So I just want to promote this group and group type to our HDA. So get the HDA window, and let's start dragging this group and group type like that. Let's apply it. So for my how I'm actually going to separate it for now, I know that the opposite sides, we have basically just a primitive. We have two primitives, and we can separate it by a primitive number. Since we have only 2, we can just give it a 0, and get from group is going to be primitives like that. And this is going to separate it by primitive 0 and 1. So put down a group node, and let's actually, once we have separated it by expression or by user defined expression. We want to give it internal names because we're going to use a wrangle, and it's going to be easier for us to work in a wrangle with the names that doesn't change. Let's put it as a primitive, as a point. Let's call it and give it something with the prefix that you won't likely use it as a in anywhere in your network, because we do not want it to be we do not want it to actually interfere with the other parts. So let's call it with other groups you all have already defined outside this network. So I'm just going to give it something like this: group 1 and group 2. So now we have our points given the given names of our groups. Now we can merge them together. Let's put down a wrangle node. Let's just connect it up. And so in a wrangle node, let's open it up. So what we want to do is run only through half of this geometry. So that means that we want to run through the sides either 1 or 2. So I'm going to run it through side 1. So I'm just running through this side. But the geometry that's actually get inside, we can actually get the references to opposite side inside our X code. So let's go to the wrangle and let's start working on it. We want to start by getting the nearest point on an opposite group. So this is going to be by int near pt. It's going to be using a near pt near point function. So it's going to 0. And what's cool about this, that near point actually gives us option to give it a point group name that it's going to search in. So we are running to the side 1 and want to search in a side 2. So I'm just going to copy it, paste inside as a group that we want to search in, and we need to give it a position that we are searching, starting our search, which is the current position, which is at position, like that. So we have found our near point. So if, let's put it on if, and near pt is bigger than or equal 0, then we want to do something. If it has found the point, let's actually start by we're going to actually use a little bit of a, I want also in this HDA give it opportunities for newly created polylines to be subtracted to. So I want to give it a little bit more of a functionality, not just connecting the opposite sides of the point. So what I'm going to do is get the opposite position. Let's call it opposition. Let's actually give it a full name. Opposite position equals point. This is going to be the position attribute, and the point number is going to be the near pt that it has actually found, the nearest point. Now I want to give it the directions, just like in our offsetting the polycurves. I want to give it a direction vector. So direction 1 is going to be normalize. Current position v at p, subtract near position, opposite position, multiplied by the CHF, the offset, like that. And we want to create our offset parameter. So let's create it inside here. Offset equals CHF offset, like that. So now we can, instead of CHF, multiply by offset, like that. So it's going to be our new position for our newly created polyline, and we just want to do the same thing with the direction 2. We just want to subtract opposite from the position, like that. Now I want to set our attribute. We want to set the the opposite points, our new positions. Let's set point attribute. So it's going to be position. Point number is going to be at pt_num for the first one. The value is going to be direction v at p plus equals direction 1, like that. So the mode we don't need. Let me actually move this a bit. Let's put it for the second one. That's not 0, that's a position. And for the position, we went to our nearest point on the opposite group near pt. Is going to be opposite position plus direction actually 2, like that. So we have, let's create this. Actually, let's start. You can see we are already offsetting this this curve, and all we want to do now is go ahead and create a new primitive. Actually, do not even need to reference it. Let's create it. Add prim. So geo handle is going to be 0, and the type is going to so we need a polyline at pt_num, which is the first position, which is now a different position. We have updated our position, and the second point is going to be the near pt, which is this one. So we need to give it 2 position numbers, like that. So you can see we have given two opposite points are now connected. And this is the re-recording of the next steps, because the video file I created actually was corrupted. So I'm just going to re-record what I did. So inside here, what I did is, so for us not to deal with the primitives after we have connected our opposite points, we can just put down an extract all point before the wrangle node, and make sure that both of these are actually the points, because I actually had aside one, it was actually a primitive. So yeah, so make sure you did that. And also I added this offset to my shed builder HDA on top of it, like that. So yeah, so this is what I did for next steps. So but for to further expand this HDA, what I'm going to do is actually allow the implementation of the deleting the points at the, so basically because of the our shed is inside here, and if I starting to put basically let's put in a sweep, I'm going to start sweeping all of this geometry. Before that, you can see it's going to intersect inside here. So what I want to do is just have an ability to delete the first and last point of this geometry, of the input geometry that we are giving it our HDA tool. Let's create a new wrangle node. This wrangle is going to sit right before, we're going to put down a couple of switches, but for now, let's just create the Vex code. Let's open it up. So we're going to run through all of the primitives. So put it run over the primitives, and assumption is that the user has put down feed us the polylines. So this is the assumptions we're going to work with. So let's go here and let's get the how much of a subtraction we want. So basically we want to just not to delete the first and last, but let's say I want to delete two from the end and two at the beginning. So I want to create a integer value to select that. So integer, let's call it sub amount, chy, let's call it the subtract, and let's if subtract amount is bigger than 0. So basically if we want to subtract, let's do something. So int, let's get all the primitive points. That's going to be array prim points. So the primitive is going to add prim primitive number. Now let's create the integer. We're going to store all of the points that we want to delete. To delete array of the to deletion. So let's get all the start points. Start PTs. That's going to be array, and all we want to do is slice this primitive PTs. So what we do is prim PTs, and we want to, inside the square brackets, we want to slice it. So we want to start from the beginning, and we want to select the amount that we have selected, which is a sub amount. So this is going to create a new array, which is a start PT. So let's start it. Let's name it get start PTs, and let's copy it, and let's call it get end PTs. Paste it. So it's a start end PTs. So in this slicing is going to be we can use a negative amount as a slicing. So when to put down a sub amount at the beginning, oh my bad, it's going to be negative. So basically negative means that we're going to start from the beginning, and with the and then we can put down these colons, and that's it. Basically we are starting. So this is going to be the end, and we're going to select the last let's say we want to select 2. We're going to select last 2 points from the primitive, like that. All we can do there now is append to delete start PTs, and also to delete end PTs. And right, now that we have created these, all we have to do is run through the to delete PTs and delete them. Do it for each. PT, and array is going to be to delete. One thing I did wrong is to delete is actually inside if statement. So what I'm going to do is put down this for each also inside it, because we want to delete only if there's a selection. So remove point. The point number is going to be a PT, and that's it. So let's start by looking at. So you can see at the 0 nothing happens, but if let's say we have 2, you can see our curve is gradually shrinking. So let's do a resample. That's wrong. Let's resample like that. You can see we are shrinking our selection like that. So now we have to put down a couple of switches to make sure that to add this to our UI, not this one, to this one. Let's add a switch like that, and the switch is going to actually control our let's add this as a parameter. So go to the HDA parameters and drag this input inside here, and instead of input, let's call it lines maybe. Something like this. Instead of type integer, do it as a toggle like that. So now if we go outside here, we can toggle it, whether we want to shrink it or not. So that's good. And let's also add the subtract amount. So let's add another folder. Let's call this as a free process. So this is because of the these This is before we actually create the new polylines. It's going to pre-process and subtract amount like that. Add it also to this like that. And what you can do is actually enable this subtract amount only when the shrink polylines is at 1. So copy this, go to the subtract, disable when get these squiggly brackets, shrink equals. So we want to disable when this is 0. That means if we do not want to subtract, this should be disabled. You can see like that. You can see this is working. And for our offset, let's create another folder. Let's copy this. Let's call this post process. This is going to be where we're going to add our offset. Actually, I already had this folder, my bad. Just put it inside the let's make these both collapsible, maybe like that. So now we have our group selection. Now we have our pre-process, whether we want to shrink our selection. Let's say we want to shrink it by 1. And then we have our offset. And offset is actually not hooked up, so actually it probably was hooked up, but I deleted it. By this I actually deleted the reference. So let me just go ahead this, copy the offset, go back inside this triangle and paste it back in like that. And now we have our offset also working like that. So that should be everything we need. And now let's actually set up our floor joints. So bring up the HDA parameters and in this sweep node, so make sure that in our newly created HDA, you shrink the polylines by 1 step, like that. Let's not touch offset for now. Let's go to the sweep and just copy the thickness of it. So the thickness for our floor joint is going to be the width of it inside here, because the boards are actually standing up on its shortest line. So that's why we have to thickness is going to be width for our floor joints. Put down the poly extrude, and our width is going to be the extrude amount distance, like that. And make sure you output also back like that. So this is our setup for now. All we have to do is I'm just gonna bring it back on the side. Now we want to move it. We want to align it with our foundation bigger boards. So put down match size. Put it the match size that we did for our base. Connect it inside here like that. And we want to align our max, adjust the YY with the same max, so that they do align like that. You see, they are now aligned. Only thing we have to do is now fix with our offset. To fix the overlaps, all we have to do is go ahead and copy the width of our HDA parameter. Go to the HDA, so our shed builder HDA, copy the width parameter. Go to our connect opposite points, paste inside here. So we want to actually shrink it, so put a negative in front of it, and want to divide it by 2 like that. So this should make sure that whatever our width of our boards is, it's always going to be aligned. So if you take a look at it like that, I change the width of it, you can see they're always going to be aligned like that. So after a little bit of a cleanup, my network is going to look something like this. And one more thing I actually forgot to do in our HDA is go ahead and let's enter our HDA, make sure it's unlocked. Let's actually put down a group delete before the output flag, because we create these temporary groups for our Vex code, but what to do is make sure that we also delete them, so we do not pass them outside our network. So just put down group delete and just put down groups that you created. And since my temporary group starts with the same prefix, I'm just going to give my prefix and asterisk after that, and that should delete basically all of the groups that are that starts with that, like that. You can see now, so before the wrangle, they are here, and after before the delete node, and it's here, they are no longer. So that's just to make sure we do not pass any groups outside our HDA. So okay, so after a little bit of cleanup, my network looks like this, and let's start working on our studs. So for the studs, let's get a blast node out of our after our group assignment. So let me connect this up. So maybe something like this. And we want to get our floor and our ceiling. Make sure it's at primitives and delete nonce actually, like that. Now I want to put down a convert line. This is going to be our baseline for our studs. Basically, we want to connect these two together. So put down a resample, like that. Let's give it something maybe like this. And make sure that these are not actually do not connect these paths, like that. So after this, what we want to do is put down our connect to our utility node that we just created, connect it up, like that. So what we want to do is give it a group. So we know that our first group is always at 0. So put down at p dot y equals 0. This is going to be our group assignment, and that's going to be points. So it should automatically connect them, and you can use these shrink polylines to have delete the corners of it, like that. So, and the offset we're going to work on a little bit later, but this is the basic setup, and I want to put down the sweep, and we can sweep with ribbon. You can see there is a problem because we don't have our normals set up because of the basically right now these points do not have a normals, so the sweep node doesn't know how to copy these two. To give some normals to our points, what you can do after the resample, put down a polyframe node, and I usually get the best results by putting normals as my tangent and turn off the normal name, like that. And this should make that our point normals are pointing basically to each other. So these are separate primitives. So the polyframe is going to take them as a separate geometry, and basically all the points are going to point to the next one, like that. So this is the basic setup that we're going to use. Our normals of our points do not actually follow each other. You can see, ideally we would want to make sure that our polygon normals are all clockwise or counterclockwise, but you can see for every one of these primitives, some of them are clockwise and others are counterclockwise. So that's why we want to make a little bit of a different setup for us. So get this convert line, go to the actions and create a relative reference copy. This is just the same node with all the relative, basically, which follows this node, and control click on connect path and connect it. Make sure this is connected. So this is the only difference between this and this. So that means that even though this is all of these polylines are different, in this node both of these are the same polyline, like that. And now let's give them some groups. So I'm going to make sure it's at the primitive groups. I'm going to call it cut lines, copy it, and let's call these whole lines. And now all we want to do is merge them together and then feed them to the resample. In resample, make sure that it's resample by polygon edge is turned on, and they should make sure that all of our resample, our hole and cut lines actually follow each other, like that, and our corners are not changed, like that. After that, we want to put down a polyframe just like here, but you see for our whole lines, the at the end of it, the normals are like halfway to the next one. So make sure that it's actually at the first edge. Instead of 2 edges, first edge normals like that. So that's good. So this connect opposite point should work still fine. But before that, we want to transfer attribute. So inside here, we want to put down a split node. Now let's split it by our polygon group, by our basically our cut lines. So now this is just a cut lines. So you can make sure that this split works by selecting some of these points and make sure that it's exactly one point selected. Put down a transfer attribute and connect these two up like that. And in attribute transfer, transfer our normals like that. So now we should get all of our normals actually following the clockwise or counterclockwise directions like that. Now connect it inside here and actually connect it, shrink it like that. Go to the sweep, extrude it. So you can see, now our extrudes are actually following correctly. Also out back. See, now we are clockwise. All of them are following clockwise this direction like that. And now I want to give the correct values for our sweep and our poly extrude. So go to the control, so the width of it, copy relative width of it. So this is going to go inside the sweep. And the thickness is going to go inside the poly extrude distance, like that. So this should also make sure that you also output back, like that. This should make sure that our bottom plate, basically our bottom plate is the same size as our studs and all of that. But the problem right now is that we need to also offset this on top of our bottom plate. So go ahead and after the connect opposite points, add the transform node. And we just want to add it to the y direction, and the amount that we want to add it. So the group is going to be the same as our connect opposite points, which is p at dot y0. Just copy it, put it inside here. Make sure that it's at points, and we just want to copy the thickness of our stud board like that and paste inside like that. And this should make sure that our polylines are always at top of it like that. Let's turn off these visualizers and let's take a look at it. And also almost forgot to make sure that you do not recompute affected normals like that, because this transform node actually affects also the normals, and if we recompute them, the sweep is not going to work. So make sure that you do not recompute affected normals on transform node like that, and this should make sure that it actually works like that. And now our stud should always be on top of our bottom plate like that. And now I managed them all together and gave a little bit of a color so we can separate them. And you can also put down a bevel to get a little bit more of a details around every piece like that. And now all I want to do is to also our bottom plate, we want to copy it to top of it. So go to our bottom plate and put down match size, connect it inside here, and want to get our stud, and we just want to put it inside here like that, maybe something like this, and want to our minimum of our bottom plate to the maximum of our studs like that. And then we also want to merge them all together like that. You can see we have basically created our frame almost, and you can go ahead and go to the box and play around with the size of it like that. And let's also add some of these resample values to our HCA. So we are now using two places resample, which is the floor resample, basically our floor floor joints and our resample for our studs. So let's go ahead and create a new folder. I'm going to copy this one. Let's call this resample values. And let's just apply it, and let's just drag out these samples. So resample of the, let's call this floor joints, like that. And also let's get our stud resample, which is right here. And apply it. So okay, so let's go back to our poly bevel. Let's get our samples for the studs and for our floor joints, like that. So okay, we have these values, and now let's actually start working on our windows and doors.